All right, welcome everyone. Sorry for the inconvenience, classic IT stuff. I'm very happy to welcome you today. This conference is organized in the context of my ambitionic grant on the metaphysics of quantum gravity. And so it's my great pleasure to have this event that will try to foster some thoughts, to help the field to build up. And so this project is made in the context of the broader project of establishing the philosophy of quantum gravity on firm grounds. As you all know, a project that has been headed by Chris and Nick. So I really hope that we will be able to make progress during the event. And so we are very lucky to have Sam Baron as our first speaker today. So Sam is based at the Australian Catholic University. He's a professor there, and I've been working with him on some metaphysical aspects of the field. I've been very happy to do those works with you and to cross the Swiss perspective with the Australian perspective. So yes, that's great. Please take it over. Thanks.
Thanks, Baptiste, and thank you very much for the invitation to be here. Very happy to be in such a beautiful location to talk about philosophy. Sorry. It's moving here, but not there. Haha. Thank you. All right. So I'm going to talk about timelessness. And a lot of the work that I've done so far is focused on this first thing here, partial timelessness. The idea that time doesn't exist, but at fundamental levels, but maybe that at non-fundamental levels, it does exist. And the thing that I'm really interested in, though, is the second thing, this idea that time doesn't exist at all. That once you start looking at some of these fundamental physical theories, it opens up the possibility that time has just gone from our metaphysics completely. And one of the reasons that I'm interested in this is because of this, what I'm going to think of, the emergence question. So there's a question about, if you get rid of time, how it is that you, at the fundamental level, how it is that you might get it back at non-fundamental levels. And I think this is a really difficult question, at least metaphysically speaking. It's hard to know how to get time out of a fundamental reality that doesn't have time in it. And of course you can tell some different metaphysical stories here, you can come up with some accounts of how this might work, but there are some reasons at least to think that you might want to avoid this question entirely. So Baptiste has argued that there's a kind of potential explanatory gap here that's analogous to the explanatory gap that you have in the philosophy of mind between fundamental physical states or neural states and mental states. And I've also argued in a couple of places that the standard tools that we have in metaphysics for understanding how one thing comes out of another thing start to become a little bit sketchy, I think, once you apply them in a region where the fundamental reality doesn't have time in it. And so you get these issues like with mereology and functionalism and other kinds of approaches that we use to classify emergence. You get sort of what I think of as a kind of almost conceptual breakdown with some of these tools. It seems like they're born and bred in a spatiotemporal context, and then when we apply them in this context, they don't fit so well. So what I like about the idea that time doesn't exist at all is that you don't have to answer any difficult metaphysical questions about one thing coming out of another, about the emergence of time from something that's not temporal, or the emergence of space-time, if you want to think of it that way, out of something that's not spatiotemporal. And this is similar to a move that's made in the philosophy of mind, right? So eliminative materialists get really worried about trying to get conscious states out of physical states, and so people have suggested just getting rid of consciousness completely. So that's sort of similar kind of move here. And I'm just interested in whether you can make it work. Now, I think that there's a strong argument that looks like it just rules this out as an option. And the argument relies on notions of empirical coherence. It's an argument that Nick and Chris have outlined. You've also got versions of it, I think, in Richard Healy's work, and sort of kicking around in other places as well. The basic idea is that if you want to have a functioning science, you want empirical confirmation, and empirical confirmation is just this thing that needs time. And so if you start to try and get rid of time completely, you might lose empirical confirmation or notions that empirical confirmation relies on, at which point you might just not be able to have a kind of functioning science.
Or a conference, like how do we start our talks on time?
Exactly. Right. So what I'm going to try to do is focus on this notion of empirical confirmation and try to work out whether you can have empirical confirmation without time. And so the idea is like, okay, if you get rid of time, what kind of structures do you have left available to account for something like the confirmation of a scientific theory? Okay, so first of all though, I want to start by clarifying what it is to get rid of time. And I think that if you start to look into the philosophy and the physics of time, there's lots of different options for what we might mean when we start talking about time. I think that there's at least 4 different options that we can think about. The first option, which is a sort of not super friendly in physics spaces, I suppose, is the idea that time is an A-series ordering of things. So an ordering of things in terms of past, present, and future. The kind of thing that McTaggart, sorry Siri, I'm busy. The kind of, I think series is setting off Siri. The kind of thing that McTaggart talked about that he thought didn't exist, right? And that, you know, you've got many arguments against the existence of the A-series subsequent to that. Another thing you might think of as time is you might think it's a B-series ordering, so an ordering in terms of earlier and later than and simultaneous with. Another thing you might think time is a kind of C-series ordering, so this is an ordering just a betweenness relation between events. You don't think of it as having a direction like you do with the B-series. Or you might just think of time as the time-like axis of a space-time manifold. So you might just think, well, whichever axis that is, that's the thing that we mean by time. And so I think partial timelessness is the idea that these things, some of these things, maybe all of them don't exist fundamentally, but one of them might emerge at some non-fundamental level. And then the idea that I'm interested in total timelessness is that all of these things are gone. And there might be other things that you mean by time, and we can talk about that later, but I'm just going to focus on these 4 things. Okay, so here's the rough argument from empirical confirmation against this idea that you can get rid of time completely. So the idea is that some scientific theories are confirmed by observation, and you kind of need that in order to do science. And you can only confirm a theory by observation if you've got one of these notions of time in play, right? So if there's time at some level, then you can have observation. If you don't have time at some level, then you can't have scientific observation. And so you have to believe in one of these notions at some, either fundamentally or non-fundamentally. And so the conclusion of this kind of argument, very simple argument, rules out what I'm calling total timelessness. So it's this argument that I have in my sights. So what I want to suggest is that this sort of argument is really a cluster of related problems. I'm going to break it down into these different problems and then have a look at each problem. I just want to try to convince you that maybe the argument's not conclusive. That's as much as I want to try and show you. I don't want to show you that, of course, time doesn't exist or something like that, or that we can fully address this argument. I just want to try and cast doubt on this kind of argument. So I think that there are 3 related problems here. The first one is I'm going to call the problem of dependence. So when you think about observation and how observation works, it looks like you need some kind of connection between observers and the world. So my observations need to reliably track things that are in the world in order to count as observations. And there's some story to be told about what that tracking relation is and what that connection between me as an observer is and the world. And I think there's a kind of dependence relation. And one way to sharpen up this problem of empirical confirmation is to think of this dependence relation as causation. So if I stand in causal relations to located objects, well then that's one way for my observations to reliably track those things. But of course, many people think that causation requires time, so if you need causation to understand observation, then it looks like you're going to need time in order to have observation as well. So this is the first kind of connection, that time is necessary for this dependence that you have in empirical confirmation. The second kind of problem is to do with location. So in order to make observations to support a scientific theory, there have to be things out there located somewhere in specific places for me to be able to observe them. Right? And if you don't have time, then you might think, well, things just aren't located in the sense that you need them to be located in order to be able to conduct scientific observations. So the idea here is that time is necessary for the kind of location that you need to support empirical confirmation and observation. So this is the second kind of connection, that time is necessary for location. Third one, and this is, I think, the hardest one in some sense, there have to be observers in order for you to be able to have empirical confirmation. So if you don't have people kicking around with mental states that count as observations, then you're not going to be able to have observation in the sense that you need to support a scientific theory and to confirm something. And of course, some people are going to say that mental states and observers require the existence of time in order to exist. So you can't have beings like us with mental states without time. One way to cash that out is in terms of a causal connection again. So you might think of mental states as relying on causal relationships, as in the case with functionalism about the mind, where you specify mental states in terms of functional connections between inputs and outputs, and so you've got causal relations in, causal relations out. So if you don't have causal relations, maybe you can't make sense of functionalism. That would be one way to think that you don't have mental states enough for observation. You could also just think that mental states supervene on temporally extended patterns of neural firing, in which case you kind of need the temporally extended patterns in order to have the mental states. All right, so what I want to do is I want to take each of these problems and just try and recover these three things that it looks like you need for empirical confirmation without time, and suggest that maybe time is not actually a necessary feature of this as well. And it's kind of very difficult, right? That last one is going to run us headlong into the mind-body problem and issues to do with how you get mental states at all, right? And I think that that's in there. I think that that's one of the issues with this kind of argument. All right, so I'm going to just take each of these three things in turn. So the first thing, why do observations need to depend on things? So why do we have this connection? Well, as I said, it's got something to do with a kind of reliable tracking. You need to be able to say that your observation, in order for an observation to count as the kind of thing that can support or disconfirm scientific theory, there needs to be some reliable connection between your observation and the world. If the connection is not reliable, then although you might have an experience, it's not going to count as an observation of the relevant kind. It's not going to be strong enough to support a scientific theory. And so that's why causation starts to look quite natural, because that's going to provide a reliable connection between you and the world of the right kind. So I think causation is a very natural kind of connection here, and if you assume that time is necessary for causation, well then you've got a problem. At least I've got a problem. So one thing you can try to do here is give up the connection between causation and time. So you can say, well look, causation can exist without the existence of time. I'm actually quite sympathetic to that, but I've received enough pushback on the idea that you can have causation without time to try something else. And so what I want to do instead is try to give an account of dependence of the right kind that can support scientific confirmation that doesn't even require causation, but it uses some of the sorts of things that we might use when we're thinking about causation. So what I want is some way to understand a kind of systematic covariation between observations and the world, so that we can have support for scientific theories. And one way to get that is, rather than thinking in terms of causation, is to think in terms of counterfactual dependence. So if it's the case that were the world to be different, my mental states would be different, or were the world to be different, my observations would be different, and that's a kind of reliable pattern in each case that I make an observation, well that seems like it can do the kind of work of connecting up my experiences to the world in the right kind of way for empirical confirmation. So I'm going to replace a kind of causal connection between my experiences in the world with what I think of as a counterfactual connection. So if my experiences, my observations, systematically, modally co-vary with the way the world is, so different possible states of the world co-vary with different possible observations, well that's going to be the kind of thing that enables a reliable tracking. And we can sharpen this up if we want to with interventionist framework. So we can say, well, look, if you were to intervene on the world in certain ways, well then my mental states would be different and my observations would be different. We can have a fairly precise account of how that works by drawing on standard interventionist technologies. Okay, so what I want to say here though is that counterfactual dependence does not imply causal dependence. So you can have counterfactual dependence, but you don't have to think of counterfactuals as causal. So this isn't a way of just sneaking causation back in, I don't think. And I think that there's lots of reasons to think that counterfactual dependence is just not sufficient for causation, and so merely having counterfactual dependence shouldn't lead you to think that there's causal connections in the world. And I've given some examples of this on the slide. So if you think about the relationship between a diamond and its molecular structure, if you were to alter the molecular structure, you would end up altering the diamond, but I don't think that's a causal connection. I think it's some other kind of connection. But there's a counterfactual relationship there nonetheless. I've also talked about in other work mathematical counterfactuals, so if facts about the numbers had been different, then certain things would follow, and I don't think of those as causal counterfactuals either. So I think that there's lots of counterfactuals that don't support causation. You could think, as Al does, that there's a broader notion of causation, such that these would count as causation. If you think that, then I'm happy to admit that there's causation of that kind, because I don't think that that kind of causation needs time. Okay, next thing, location. So you want things to be located, and the question is, does location require time? And I think if we think about what location is, just in the ways that we use it in philosophy and in science, where am I? We don't necessarily have to think of it as temporal. I think we can think of location in all kinds of ways. What's important is that location, that whatever notion of location we have, and I think you can have location without time, whatever notion of location you have, it's sufficiently robust to support empirical confirmation. Whether that involves time or not is less important than whether it actually gets you what you need. And I think that location supports empirical confirmation in at least 3 ways, and I'd be interested to hear if people have other ideas about how this might work. So one way in which location is important is it provides individuation. If you want to say that an observation of X is a different observation to an observation of Y, you want to be able to have some way to tell X and Y apart, even when they're qualitative duplicates. So even when they share all the same intrinsic properties, you might well still want to say that the 2 observations are different, and location plays a really important role in that. You can say, well, look, they're pinned to different regions, and that's the basis for their differentiation. I also think you want to individuate observations. So you want to say one observation is different to another observation, even when they're qualitative duplicates. So even when the observations might have all of the same intrinsic properties, you still want to say that 2 observations are different, and one way to do that is to say that they happen at different locations. I also think that in many areas of philosophy, there's something like a co-location constraint on epistemology. And you see this in certain places. So think about the philosophy of mathematics, where people get really worried about mathematical objects existing outside of space and time, and that somehow the fact that they're not located in the same space as us seems to undermine our capacity to access them epistemically. And so it looks like one of the things that location might be doing for us is putting constraints on how epistemology works and providing a kind of general arena within which we can carry out confirmation and epistemology more generally. So I think that location does these 3 things. Does location need to be temporal in order to do those 3 things? And I don't think it does. I think that there are lots of notions of location out there. I think, we talk about location in a structure. When we think of structuralism about mathematics, you say, look, the number 2 is a node in a structure, and you think of that as location. You talk about location in a similarity space. Think of a metric space over properties like a color solid, where you talk about the distance between red and green in the color space. We talk about location in a modal space, like in Lewisian possible worlds. We think about the distance between points in a modal space. We talk about location in configuration spaces, pure geometric spaces, locations in graphs. A lot of this location talk is, used in for very different kinds of things. And you could just think, well, look, maybe this is just metaphorical or something like that, and where the location really means location in space and time. But I just don't see any motivation to think that the use of location here is metaphorical. I think we literally mean location. It's just that location doesn't require spatial or temporal notions in order to be operative. And I think there's a really minimal notion of location here. And I think as long as you've got a structure of points with a metric over them, you can have some kind of location, and that's pretty easy to get, really, and you can throw that over all kinds of different structures. So I think there's a very minimal notion of location that we can use here. And I think this minimal notion is enough for the 3 things that I pointed to. It's going to individuate things. As long as you've got a sort of distance relation, you can talk about whether 2 things are, how far apart 2 things are, and whether 2 things are sort of co-located, then you can talk about individuation of both objects in the space and observations in the space. It also, if it's one space, right, if it's one connected space, then you can also talk about co-location in the space, and so you can address this kind of need to have everything located within a single arena, if you like. All right, so as I said, I don't think this minimal location requires temporal notions. I don't even think it requires spatial notions. Of course, we use the word space, but we're not talking about physical space when we do this, right? It's some more general notion. All right, last thing. Actually, before I get to the last thing, so I'm gonna say that there are certain kinds of locational structures that support empirical confirmation. So not all structures of locations might do this, depending on exactly what location turns out to be once we dig into it a little bit. But I think that if a system of location supports empirical confirmation, insofar as it supports the location of observers and things to be observed and connections of counterfactual dependence between them, so it has to do that as well. So the structure of locations kind of has to support the idea that if you intervene in one location, then something will happen at another location, so it has to do that. As long as it can do that, then I think it can support empirical confirmation. I'm going to call that kind of structure an empirical structure. And I don't yet, as I said, I don't think it needs to be spatial or temporal. All right, now the hard bit. Observers. So this is going to just, as I said, take us right into difficult issues about philosophy of mind. In some sense, I think that works in my favor, right? Because I don't think anyone's in a position to say, oh, this is what the mind is, right? And thus, it requires time. Like, if we could say that, I think we would have a much better sense of the physical basis for mental states than we actually do. So in some sense, I think there's already space here to think, to push back against this argument to some extent and think, well, look, observers might require time, but they might not. We don't actually know what the basis for observation is yet. But I don't want to rest there. I want to push this a little bit further. So what I'm going to do is I'm going to try to show you that it's possible to have minds without time. And I'm going to do that by taking a theory of the mind and trying to sort of show you that it still works even when there's no time in the neighborhood. So I'm going to start with functionalism. So here's what this is a kind of thought experiment that I'm going to run here. So start with functionalism. Assume that a state is a mental state if it plays a particular functional role. Pick your favorite form of functionalism. I don't really care. What's important is that functionalism is sort of specified in causal terms. And I'm also going to adopt a counterfactual theory of causation of the kind, Lewis, circa 1973, counterfactual dependence is necessary and sufficient for causation, right? The strongest form of the counterfactual theory of causation you can imagine. Put those two things together, and you get the idea that counterfactual dependence is necessary and sufficient for mental states, right? Because counterfactual dependence is necessary and sufficient for causation, and causation itself is suitably cashed out is sufficient for mental states. Now what I want you to do is imagine the following possibility. This is a situation in which mental states are still analysed in terms of their functional roles. The functional roles are still analysed in terms of causation, and causation is reducible to counterfactual dependence. And there are physical states that satisfy the mental state role. So we're going to imagine that there are minds and that this theory is correct, right? Now I want you to imagine another possibility where what I do is I still accept that mental states are analysed in terms of their functional roles, the same functional roles as in the first case. The physical states that realise those the functional roles exist in this other situation. So it's sort of a physical duplicate of the first situation, and it's a functional duplicate insofar as functionalism is still true there, and the relevant things still play functional roles. So every counterfactual linking the physical states in the first possibility still links the physical states in the second possibility, but causation is not reducible to counterfactual dependence. So in this situation, we don't accept the counterfactual theory of causation. And we admit that we also accept there's no causation in this situation. So what I've done is I've taken a world in which functionalism is true, and it's a sort of physicalist version of functionalism, and functional states reduced down to counterfactual dependence relations. And then I've moved to a possibility in which I've kept everything except causation. So I've kept all of the counterfactuals, I've kept the connection between counterfactual dependence and mental states, but I've shedded causation. My claim here is that if there are mental states in the first case, there are mental states in the second case, because what's doing the work is counterfactual dependence, not the fact that counterfactual dependence is sufficient for causation. It doesn't seem to me that causation really adds anything over and above what counterfactual dependence is already doing in granting you mental states in the first situation. So when you move to this other situation, you sort of keep the mental states, but you shed the sort of extra metaphysical baggage around causation. So here's a case in which I want to say we have mental states, but we don't have causation. And I think that, so that's the first step. Now I want to do that and also get rid of time. So I want to keep all of the counterfactual dependence relations, I want to keep the physical states that realize your mental states, but also get rid of time in that situation. So no causation, no time. Again, because counterfactual dependence is the thing that's doing the work in grounding mental states, my view is that we keep mental states even when we get rid of these other metaphysical aspects of the world that we might have in a world where we have the mental states with those physical, with those metaphysical aspects. Okay, so if that's right, and I'm not at all sure it is, then I think counterfactual dependence is sufficient for mental states. Counterfactual dependence doesn't require the existence of time, so it looks like you can have mental states without time, as long as you have the right counterfactual connections between things. As long as it's the case that were I to pinch and punch someone, that they would yell and yelp, and as long as that sort of thing is true, right, and notice that that sort of thing doesn't require saying anything about time, it's just a high-level functional claim about the relationship between pinches and punches and yelps, well then we can have mental states, at least enough for observation. And that's it. Thank you.
Now we are going to listen to Jordanowski. We're going to make a welcome.
Okay, does everybody have a handout? Don't worry, it looks long, but I've been asked to do 5 minutes, so it's not going to be more than 5 minutes. Thank you, Sam, for the paper, for the talk. Thank you for sending the slides in advance. They were very detailed, so I prepared some comments based on that. So they are entitled questions, and in a place they look like objections, but basically what they are invitations for you to say a bit more about some of the points you mentioned. So the first question concerns the causation covariation issue. So just to sum up where we are. So the argument, the rough shape of the argument is some scientific theories are confirmed by observation. Observation requires time, and time exists, at least not fundamentally. That's the argument. And the causal dependence version, observation requires causation, causation requires time, so time exists. And what we need here, so the key notion here is that we need reliable tracking. Okay, so and causation would provide that, but you don't want causation. Okay, so what you want is to have reliable tracking without causation. And you say that systematic model covariation is enough. Okay. Now the question is it really enough? So in general, and you agree on that, covariation is not causation. That would not fit what you want to do anyway. So the question is, what does tracking or reliable tracking mean here? So for instance. Just as a general point, across all possible worlds, all necessary truths and necessary falsehoods systematically covary, but that doesn't make one to track the other. So that's systematic covariation in this sense would not be enough. And so the question is, what is it that makes the tracking? It seems that, so this is like I put it a bit like an objection here, that the theory proposed here is kind of magical. It doesn't explain how the tracking works or what the tracking really is. And to try to make this clearer, I used the example you used about the diamond. So the issue here is not the relationship between the hardness of the diamond and say the lattice structure of the diamond. That's not really the question. In this case, we could have the idea that the relation of tracking could be based in the simple meaning. We could say that hardness, when it comes to diamond, simply means having this lattice structure. So tracking could amount to that. Okay, but that's not really the case we need here. What we need here is the second issue that last on the first page of the handout, the relationship between an observation of the hardness of the diamond and the hardness of the diamond. And here is nothing like meaning or something else that could explain the tracking. So what we need is a link between these two things, the observation and the hardness of the diamond. And we need some kind of understanding of why and how there is this observation. Well, it seems to me that under the proposed account with mere covariation without causation, there appears to be something like an explanatory gap. Okay, so that's the first question. If you can say a bit more about that. Okay, second question concerns the notion of empirical structure, and it's going to be a similar question. So it's it's an invitation to say a bit more about the key notion you have here. Okay, so the empirical structure. So here I copy pasted the 1, 2, 3 points from your slide. So observations and observers are located. Variables are located. There are appropriate relations of counterfactual dependence between co-located observations and variables. And you insist on the idea that located does not have to mean temporally located here. Okay, so that's the point. Now the question is, okay, it doesn't mean temporally located, but then what does it mean? And so you gave a list of different types of locations. I think that's entirely relevant to show what you wanted to show, namely that location doesn't always have to mean temporal location. So I agree on that. So I listed them here again. I copy pasted from your slides: mathematical structure, similarity space, model space, and so on, so on. And the idea is that observations and variables are not relevantly located in any of these senses, and they are not, for you, located in time either. And so the notion of empirical location, since it isn't any of these things, and since it isn't temporal, seems to me a bit underdefined, underexplained. So again, I wanted to invite you to say a bit more about what it does mean, as opposed to what it doesn't mean. Okay. Third question, it's really a very minor, maybe terminological or exegetical point, because this is something I'm interested in, because I've been doing work on eliminativism. So you mentioned the idea at the beginning of your slides that total timelessness is analogous to eliminativism about material objects, but at least as far as I understand eliminativism, objects like tables or chairs, they exist in a non-fundamental way, derivative way, like atoms arranged table-wise, if you take Merrick's or Inbagin, or conventions, if you take other types of eliminativists and so on. So does the analogy really hold between eliminativism about macroscopic material objects and the total timelessness view? But really, it's probably a terminological question about what we mean by eliminativism, but yeah, if you want to say something about that.
Mm-hmm.
Okay, and the last question is really a question coming from somebody who does metaphysics and who doesn't do much philosophy of science like me. So maybe for you this is obvious in the kind of debate you're having, but for me I just wanted to know a bit more about why you want to eliminate time. So you mentioned at the beginning of the talk the possibility of not total timelessness, but the partial timelessness, but you still choose the total timelessness. So why is it so? Why don't you like time so much? Okay, that's I guess it was 5 minutes.
Yeah, thanks.
Okay, thanks.
All right, so I suggest that if you want to take 5 minutes to answer Jerry, and then we go to it.
Yeah, sure. So I think I can go through fairly quickly. So the first idea is what, systematic modal covariation is not enough. What do I need? So I think the more that I want there is something more like the kind of interventionist framework. So it's not just systematic modal covariation in the sense that when you look across possibility space, you see that certain things happen in the same possibilities and certain things don't happen in the same possibilities. So, like all necessary truths all modally covary. It's not so much modal covariation in that sense. Rather, it's modal covariation closer to the interventionist sense, where if I set up a system and I've got variables for each of the aspects of the system, if I were to alter the variables, then there would be a change to some other aspect of the system. So what I want is modal covariation, a kind of interventionist kind, and I know that that's going to sound very causal, but I don't think that interventionism needs to be causal, right? I think the whole framework of interventionism is kind of agnostic about whether it's causal or not. I think Woodward assumes that it is, but I don't think you have to. So it's more like things need to be handles for other things, right? That's what I want. And as long as you've got that, and as long as bits of the world are handles for observations, then that's the kind of reliable tracking that you want. And that's going to be rule governed by whatever the rules of the system might be. So second thing, what is this idea of like, okay, I said what these things aren't, but what is the system of location? So I didn't mean to say that it's not one of the things that I listed. It could be one of those things, right? I was just giving those as examples of spaces that don't have time. But a kind of structure that supports empirical confirmation could be one of these. It could be that, you know, the fundamental structure is a configuration space. There are counterfactual relations between things in the configuration space, and maybe that's enough for empirical confirmation. In general, I want to kick this over to physics and look at what the sort of fundamental structures you have in physics might be that might provide a system of locations. So for instance, if you look at some of the things that people will be talking about later on, things like loop quantum gravity or causal set theory, you might not have space or time down there, but you've got structure. And I think that that's really important. And you've got structure enough, I think, for there to be rule-governed interventionist counterfactual relations between things. And I think that that could be enough for empirical confirmation. Maybe you don't need to then plug time back into it at a non-fundamental level. The analogy with eliminativism, I was thinking of eliminativism in the philosophy of mind, in particular, of the kind where some people say consciousness doesn't exist. Right, so it's not that it exists derivatively, they think it doesn't exist at all, and people think that's crazy, right? Because, of course, consciousness exists, just introspect. And I think you can think of denying the existence of time as similarly crazy, and it's that kind of view, but it's not the view of like, you know, the sort of Merrick's view where you give up, where you say tables don't exist fundamentally, but they exist non-fundamentally, or there are symbols arranged table-wise, however you want to cash that out. Motivation-wise, I guess the motivation for me comes from, you know, you look at some of these fundamental physical theories, they don't seem to have space-time in them. They don't seem to have, in some cases, even spatial or temporal structure, although I think that might be more controversial. But you want to try and get spatial and temporal structure back somehow, right? And I think metaphysically that is hard. And so that's kind of the motivation for me from there. But I think there are purely philosophical motivations that you can have. And one of them is a kind of parsimony argument. If we can do without it, then let's. And I think we can do without it. So that's why we get rid of it in sort of a more general sense. That's it. Yeah. Thanks.
All right, thanks. All right, time for discussion. I suggest using the classical hand finger system. So please, then Lorenzo, then Vera. But if you have finger in the meantime, just.
Great. Thanks, Sam. And I think this question is going to be related to Jury's first question. Because it sometimes sounded in the first part of the talk as if it was kind of all you needed was counterfactuals plus time, and you got causation straight out. But of course, there's this kind of long-standing problem of where kind of how you account for causal directionality. And one big role for time that a lot of people attribute it is to kind of causation can inherit its directionality from time. Maybe it's the other way around, but without time, kind of you might think it's not enough to have the counterfactuals. You also need a kind of directed kind of counterfactual. So where is the kind of counterfactual directionality going to come from?
Yeah, sure.
If not via time.
I guess two things. First thing is that the attempt to get the direction of causation out of time has not fared well, I don't think. So it's not obvious to me that, like, you know, time is going to do the work for us anyway. But I guess the thought is that, you know, and I don't know exactly where the directionality is going to come from, but I think that you could find that there's some sort of other physical asymmetry which accounts for this kind of directionality. And it depends on what we discover from the science of it, I think. So, you know, I want to leave that question open to some extent. If I had to, I guess I could stick it in by hand and say, well, look, you know, some interventions work in one direction and not in the other direction. Even in Woodward's picture, that's not exactly accounted for in terms of time. That's just kind of taken as a primitive feature of the interventionist structure based on the directed nature of the graph, right? And so...
Yeah, well, I was just talking to Stu about it earlier this week as it happens, and he wants to trace it to a like probabilistic independence assumption,
Yep.
but that's imposed at the start of time.
Right.
And we don't kind of, if we don't have time, we don't have the start of time to impose our independence assumptions on. So is there like
Yep.
a start of the world that's nonetheless not a like a time-like start of the world, but like a kind of metaphysical start?
I think so. I think you can have that sort of thing. I also think that there are going to be probabilistic independence assumptions that don't require you to trace it back to the start of the world. You know, you could have something like you know, sort of Markov screening condition type things, which might work in one direction but not in another, and you could find an asymmetry there. But yeah, I mean, it's a difficult question, and I don't really know the answer. Yeah.
Thank you.
All right, Lorenzo?
Yes, so you make a prima facie good case for the fact that a theory with total timelessness is not empirically incoherent. And I can easily imagine, say, that you have a little man on some parts of the set theoretic hierarchy who can like look down, and if they see that there is an inaccessible cardinal below, then they think, oh man, there is an inaccessible cardinal below, and if there isn't, they don't. So this seems to be convincing. But do you think that there could be a theory which is empirically adequate? Well, so it seems to me there is something which my watch is tracking as a matter of fact. Seems that events are ordered. I have memories. So do you think that there is a theory that is totally timeless, but you also can account for that?
Yeah, and this isn't unrelated from Al's question, I think, as well, because if you think that part of the empirical adequacy issue is accounting for certain kinds of asymmetries that we observe, then you might, you know, it's sort of this plus a bit more like, also, how do you account for, you know, the success of something like general relativity or something like that, or quantum mechanics or whatever. Yeah, I mean, I guess what I want to supply is a structure, a minimal structure that gets you the capacity to empirically confirm things, but then there's going to be, like, I still think there's material stuff out there, right? And so as long as there's going to be relations between material stuff and other material stuff of the right kind, then I think you can build something that's empirically adequate. I guess one way of thinking of this is it's like hyper relationalist, right? Where it's like all you have are certain kinds of relations between chunks of stuff, and that's the sort of foundation of your metaphysics, and you build everything else up from that. And then empirical adequacy, like empirical confirmation, is just two, you know, material things entering into a kind of relationship, just not a temporal one. It's like some sort of relationship of counterfactual dependence. And then, you know, as long as you can sort of think of how relationalist pictures can be empirically adequate, I think you can transfer a lot of that over to the way I'm thinking about it. Hope that helps.
Bill?
Yeah, thank you, Sam. So my question is about the whole argument. So you started by defending the view that time is not only fundamental, but it's not even emergent, right? But then in your talk you were saying, well, look, we don't need time to explain like location or causation or whatever. But then I was wondering, well, don't you also need to say, well, look, we have, I don't know, like causation, right, at our fundamental level. But then, I mean, we, like time is not even recoverable. Like you don't naturally recover time, because one can say, look, yes, we have causation at the fundamental level. And then, I mean, you of course individuate time once you have a causation. So for instance, Asphalt defends the view that once you have a change, of course you need time. And I think he also endorsed the view that once you have causation, you have time at the emergent level. So it seems difficult to say, yes, we have causation, but we can't recover time. We don't recover time once we understand the time in a particular way, like as, you know, earlier, later, or, you know. So it seems that maybe we are not in, I mean, the situation is not really here that we can't recover time from a timeless level, but that actually once we have a timeless reality, like just a causation, then naturally we don't recover time.
Yeah, I guess I'm not quite sure I fully grasp the point, but I can see 2 points that, and I'll address them both. So one point is that I wasn't saying that causation is fundamental. So there is a view, which I'm also attracted to, according to which you take causation to be the fundamental metaphysical thing in the world, metaphysical structuring relation, and then maybe space and time come out of that, maybe they don't, right? There's a further story to be told about how that works. That's not this view, so I'm trying to do it even without taking causation as a sort of basic aspect. I'm just trying to have counterfactual dependence relations, and I refuse to think that counterfactual dependence is enough for causation, at least for the purposes of what I'm doing here. So that's the first point. The second point, though, there's something in the neighborhood that does worry me, and that's that, well, if you've got structure, at a certain point, when you have enough structure, you just get time, right? And so it doesn't really, like, okay, I've done all this work to build up enough structure for empirical confirmation, but haven't you just recovered time in the process of doing that? And that's why I sort of specified the 4 things that I'm getting rid of, right? It's time in those 4 senses. There could be some other sense of time. So you could have a very weak functionalist sense of time, according to which time is whatever supports empirical confirmation, in which case I can't avoid time so long as I have empirical confirmation. So yeah, I think there are ways to weaken your concept of time so that it's easy to get out of it once you've got certain things. So I am working with more metaphysically robust notions of time and getting rid of those. And if people want to say, oh, you've got time anyway because this is how I use the word or the concept time, fair enough. Yeah. But I'm not sure if that addresses what you were...
Yeah.
Okay.
Thanks.
Sorry, then it's James, and then Chris.
Thanks very much, it was very thought-provoking. So I completely agree that in a totally timeless theory, if it's to be empirically coherent, we're going to require a theory of observations, which in turn is going to require a theory of observers. But it seems to me that at this point it's going to be very sensitive to the totally timeless theory under consideration. What we need to do, in the words of someone like Howard Stein or Eric Curiel, is schematize the observer, show how to actually model observers in that totally timeless theory. And how you do that is going to depend very sensitively on whatever theory that you're dealing with. So I guess I kind of agreed with everything you said, but it seems to me the details are more sensitive to the particular theory under consideration. I'm just wondering if you agree with that or not.
Yeah, I mean, up to a point. So there's a sort of background thing that I'm worried about, which is like, how much do you want your notion of empirical confirmation to be determined by your science itself, right? And there's a kind of bootstrapping worry lurking here, which of something like the following kind, where, how do you get science started if you need to do science in order to work out what empirical confirmation is? Like, that's the sort of rough form of the worry. So while, yeah, I'm totally happy for this to be a general framework that you then take to a particular theory and just say, okay, well, counterfactual dependence, okay, but what does that look like? How does that actually work within this theory? What are the details? And maybe we need to add some things from the theory, maybe we need to take some things away. I'm totally happy with that, and not taking this as sort of like the theory-independent a priori structure of observers or something like that, right? Like, totally happy for that. I just wanted to see how minimal you could go, right, as a kind of starting point, and then we can work forward from there. But I am a little bit worried of just like leaving it all up to science to tell us how empirical confirmation works, if that makes sense.
That's super helpful.
Okay, cool.
So, suppose we're doing empirical confirmation. We're conducting some sort of Stern-Gerlach experiments with some sort of vertically oriented electrons measuring the spin in the horizontal direction, or the other way, or something like that. And then we see, okay, the first electron was an up electron. What does that mean? Well, on the screen, it hit the screen so and so many centimeters above the origin or the 0 axis or something in a spatial location. The second one hit it so and so many centimeters below it, and so on and so forth. So clearly we're using spatial features to say what the data is. That's relevant for empirically confirming our theory of spin. We also use, of course, time. We said the first one, in the sense of maybe a B theoretic, a B series, or at least a C series, that one was up, the other one was down, and so on and so forth. Now, you really only talked about the second one, the timeless case, the totally timeless case. And I'm wondering in what sense that would be coherent to look at, or cohere with relativistic physics, I would say, to just look at the timeless universe as opposed to a totally spaceless universe or world. So for me to be sort of relativistically consistent, it would have to be, we would have to consider not timelessness, but space-timelessness. And then if we accept that, we say like, okay, yes, let's get rid of all of this structure in the way we do empirical confirmation, including spatial ones, then I'm getting back to questions of the kind that maybe Gigi has asked and Lorenzo, and whether anything doing with any not just temporal but also spatial structure would have any chance of being empirically adequate at the end of the day. And so I'm wondering, what do you think about spacelessness, sort of parallel to timelessness, and whether that comes apart or?
Yes, I'm picking on time, but I'm happy to extend it to space or to space-time, depending on how you want to think about the world. So take everything I've said, and if you want, run it for space-timelessness. In which case, the non-existent space-time is space-time doesn't exist fundamentally or non-fundamentally. And I mean, I guess there's a further question as to whether if space-time doesn't exist, whether your theories can be empirically adequate. And I think they can, right? So I think that empirical adequacy is actually a sort of relatively low bar to hit, because it's just about, okay, we've got a sort of theoretical structure, we've got some observations, and how do the observations relate to the theoretical structure? But it's not so hard, I think, to get an empirically adequate theory. So, I mean, I guess I want to come back again to this kind of relationalist idea. So if you think about a relationalist who's just thinking in terms of relations between bits of matter and bits of the universe, and I don't see why you can't have a kind of empirically adequate story that's founded on that kind of system. And that's like really close, I think, to just getting, okay, so now just take the relations to not be spatiotemporal relations, right? Take them to be some other kind of relation. So long as you've got things that relate to each other in certain kinds of ways, you can take an object and you can measure another object using that object because you've got relations between them. And then you can talk about that in spatiotemporal terms if you want, but strictly speaking, there's no thing that you're talking about beyond the objects and the counterfactual relations between them. That's kind of the kind of thought.
Right, yes, that seems a natural answer given what you've said before, but so we would then need some sort of error theory, it seems to me.
Yeah.
When we speak of our spin measurement results of being up and down, what do we mean by that? Well, we actually don't really, it's not the case that there's any physical spatial relations there. It's something else, it's some other relations that we're talking about.
Yeah, and I mean, I guess the question is like whether you need an error theory or not, and what the going notions being used in physics are and how people are actually thinking about them, right? So it might be that physicists, when someone's conducting this kind of experiment, they have a really robust notion of space and time in mind when they're doing the observations, or they could just be talking about the readout on a screen and the readout on another screen and the relationship, some kind of dependence relation between those two readouts. And they don't really have any deeper view about spatiotemporal structure or anything beyond that. And so when they're talking, you might not need a particularly demanding error theory to actually make sense of what they're saying. On the other hand, you might, right? So it might be the case that you have to sort of take their claims about space and time to be strictly speaking false, but relating to some underlying dependence relation between things, some kind of relational structure. And then I think you do start to get into this issue with Vera. It's well, maybe that's just what we should think of as time, right? Once you've got enough structure of that kind. And so there's all issues about whether an error theory should just be a realist theory, and the better your error theory is, often the more realist it looks, and vice versa sometimes. So yeah, I don't know. Does that help?
Yes.
Okay, cool, thanks.
Yes,
yeah, thank you very much. So I'm not sure whether this came up already. Still just try it again, so to speak. Yeah, so I don't really see how you can deny that space-time, or time rather specifically, is there at least done fundamentally. And I'm wondering, so if you accept this as a lesson from our best physical theories and philosophy of time so far, what would be the role for such a project like yours? I mean, is it like what I heard out a bit from your conversation with James here? There could be still some isolated regimes for which you would propose exactly this kind of scheme of confirmation? And if so, however, how would this isolated regime ever grant the name of being anything empirical whatsoever, given that empirical does have after all something to do with experience and should be after all linked to what we also perceive as experiences? I mean, I don't know, I'm just wondering once more, like, is this a proposal for an alternative world, for how the world could have looked like? Or is it rather a proposal, actually, even if we accept that time is non-fundamental in certain good senses, still we should explore the scheme here?
Oh, I see. So even if you accept that time exists non-fundamentally,
Yeah.
should we explore this kind of schema? I think if you accept that time exists non-fundamentally, it's not obvious when you have deep problems with empirical confirmation and observation. So if you can have some non-fundamental notions of space and time, I mean, there might be problems, but at least they don't seem to be the kinds of problems that I have.
Yeah.
So this really is supposed to be for the situation in which you get rid of time completely. And the reason that I'm interested in it is to see whether it's at least an option, right? Because, here's the sort of thing that I'm worried about. I'm worried about taking the existence of space and time as kind of a priori in some sense. Like, that worries me because I don't really like taking anything as a priori. And so it feels a little bit like there's a risk of doing that if we don't at least explore the option of getting rid of it completely. And so that's sort of where this is coming from, right? So I'm kind of trying to work out, well, okay, look, here's why it looks like it might be a priori, right? Because in order for there to be experience in some sense, you have to have time, right? There's a sort of like Kantian angle there, right, in some sense. And that's what I'm trying to get away from. I'm trying to maybe make it an a posteriori question as to whether time exists.
Yeah, and could you just explain in which sense you think you could actually deny that time is fundamental? I mean, just given from what we know about time, I don't know, we have relativity theory, let's say, we have some notion of time there, we have our own intuitive theory, so how could you ever deny that there is time at least fundamentally to begin with? I was just wondering.
Well,
You just assume that.
No, I take it that, for the purpose of the talk, I assumed it.
Yeah,
But my motivation is, okay, I've got these notions of time which are certain kinds of metric structures. And when you look at certain fundamental physical theories or proposals for fundamental physical theories, it doesn't look like there's anything that satisfies these notions exactly. So whatever time, maybe there's some other notion of time that you like, right? And it's not the ones that I'm talking about. In which case, let's explore that notion and let's put it on the table as a notion of time because it's not one of the standard options that we have, at least in the philosophy of time. And so it's like, okay, so with these specific notions, these don't appear in at least some proposals for fundamental physical theories. Maybe they don't exist at all as a result. That should be on the table, is the thought.
Okay.
Does that help?
Yeah, I always think more about it when come
Okay.
to you. Yeah.
All right.
Okay, so Elena has a finger.
Yes, perhaps it's a finger to this last question. A very naive question. That is, you say, I understand the conceptual exercise, but I'm wondering, you start from correlations, structures, in a sense. Is that true?
Yeah, there's structure.
Yeah, you start.
I assume there's structure of some
something.
kind, yeah. Rule-governed structure
Okay,
is
exactly.
that supports modal claims. I need that. Yeah.
You start. If I have this structure, then.
Yes.
And who gives you these structures?
Who gives me the structure? Yeah, well, I'm hoping.
Correlation and,
I'm hoping that science will give me the structure.
Well.
And if it doesn't, then okay.
No, it gives you a lot of structures, but
Yeah.
it depends on the skills, on the domain, so it depends on a lot of things.
Sure, and I think this could be tailored to a particular scale or a particular scientific theory, right? So zooming right out, it looks like there's structure and rules that the structure follows, right? That seems to be one way to think about what we get from a scientific theory. And when you have that, I think you have enough to start thinking about, well, what happens when you change this part of the structure? Does it make a difference to another part of the structure? And that's the sort of minimal thing that I need, I think, for empirical confirmation. You can add more to that, and a different theory might add more to that. If it's got less than that, then I'm worried. Yeah. if you don't even have enough to make sense of counterfactual dependence in the context of scientific theory between whatever the sort of stuff in the theory, like whatever the ontology of the theory is, if there's no counterfactual dependence between them, then yeah, this is not going to work.
Okay, Nick, and then Lucy.
So Neil's already asked the question that he thought had been asked before, and I think I'm going to ask it again in a different way.
Sure,
But it kind
sure.
of goes really to the heart of what I'm kind of most interested in here. And I think there's still something to get at here still.
Yep.
All right, so I don't like to talk about my papers in other people's talks, but since you were that's what you.
Sure. Since I picked on you, it's fair game.
It just explains the way I'm thinking about it. So, I think in the paper, I'm not sure to what extent we were suggesting, or I was suggesting that this was a sort of a priori matter, fact about what observation is. So I was kind of looking at the paper, and we use the first person a lot. We do this, and this is what how we understand experiments. And I think that at least showed some sort of anxiety about this. I also think maybe I was okay about putting some suggestion about aperiority in there, in the hope that people would kind of pursue the question in exactly this kind of way. So I think this is really kind of great and helpful in that regard. Anyway, okay, so good. So, but let's take it the sort of, it's not a priori, and imagine that we were just sort of presenting this argument as, well, it's just a matter of fact about how, all the observations that we can, things we never counted as an observation or empirical evidence are local variables, and that's just kind of the world we, find ourselves in. So what I've heard in some of your answers is, right, I think you two have kind of gone a little bit back and forth in some of the answers, sometimes talking about the sort of a priori question, and then sometimes pushing it maybe to James a bit about what this would amount to for us. So can I ask you again to kind of press, to sort of have a go at this from the, what we find observations to be? I mean, are you going to, you started by mentioning sort of eliminative materialism about the mind, so as Churchland, there really is a sort of theory on the table about what we should be replacing folk psychology with or something. Is that implicit in the talk, or is, to what extent is that a program you sort of see carrying out? So,
the specific eliminative one?
Yeah, so, you have Chris's Stern-Gerlach experiment.
Yeah.
Could we really, at the, ordinary level that we're living and really retell that? Do you see that as possible? And do you have sort of ideas, is this a program for actually doing that?
Yeah. So I take it to be a program for actually doing that, right? So the thought is, as I understood the paper that the two of you wrote, I didn't think that you were claiming that, space and time is our priority. I said that because I was at a talk recently where someone said, okay, here's my starting point. I'm just going to assume, as Lewis did, that space-time exists. And that's a priori. Like, they said exactly those words, and that's the thing that kind of worried me. It wasn't meant to be about that particular paper. But as I understood what you were sort of saying in the paper, there was this worry about empirical confirmation, and there's this question about how you recover it. And in some sense, you have this, this sort of top-down picture where you say, okay, well, let's see what the scientific theories say and use that to inform how we understand the nature of empirical coherence, and sort of work back and forth between the theories and maybe what we pre-theoretically think about empirical coherence in order to come to some maybe reflective equilibrium. That's sort of my reconstruction of what you said, but I don't think you said it in exactly those terms. So I'm totally happy with that, and I'm happy with the talk of local variables and all that kind of stuff. The thought is just can we reconstruct all of that without having to assume that what local variable means is anything to do with space and time, right? Can we make sense of local and variable and the connection between us and such things that in the sense we need for science in order to well enough for empirical confirmation. And I kind of see it as continuous with what you suggest at the end of that paper, which is, well, rather than starting from what we intuitively think about the nature of the world and then using that to set the nature of empirical confirmation, let's see what the scientific theories say and then use that as a guide. And some of the scientific theories seem to say that space and time don't exist, so maybe we should update our notion of empirical confirmation, at least try to see if we can, to reflect that. I don't know if that's helping.
I think I want to press on it sort of a bit even more sharply than that.
Good.
So let me sort of, for the purposes here, sort of say, okay, I kind of actually buy the sort of general argument that one could have something that deserved the name observation without time, and that's. But what I'm worried about is, the specific observations that, scientists actually make of the Stern-Gerlach apparatus, or maybe that I'm making of the room at the moment. Right, I mean, the talk at the beginning of your talk, and then I observed you at the end of your talk, and I can reconstruct all those observations, those particular observations in this timeless way.
Yes.
Okay.
Yeah, that's the hope, right?
Okay.
Yeah, and I guess the thought is that, so on the one hand, I don't want to impose an understanding of observation on scientists, right? So when they're observing something in a Stern-Gerlach experiment, I don't want to say, okay, well, time exists a priori, so they must have some temporal understanding of the relation between these two things, or their language is like locking on to some pre-theoretic a priori concept of time. I don't want to make those kinds of assumptions. And I also think that we can reconstruct our observations of the everyday world in this framework. It's just the thought is that you need a lot less than you might have thought. All you need is a way to talk about the locations of things, and then some way to understand the connection between them of the kind of interventionist style connection.
Okay. I mean, so just one more. Is there a long list, or I can say?
No.
I mean, one of the things I sort of had in mind was sort of, relationist theories of time, sort of Alla Ravelli, from Problem of Time. I just have sort of coincidences of the Stern-Gerlach doing one thing and the clock next to it saying one thing. Yeah. Is that enough to kind of?
Yeah. I think it's sort of enough, right? So think of a really strong version of Humeanism where you just have stuff in a bag, right? And there's sort of you could talk about the sort of coincidences between the things in the bag. I mean, there's something like that in this kind of color Ravelli type picture of just matter on matter and all these relations between these fields. It's in that vein, but I want to add a little bit more structures. I want modality, right? So that's the sort of difference I think between me and what I'm saying here and maybe some of the things that Ravelli says. At least he doesn't talk about modality, at least in the things that I've looked at. That's a hefty assumption, but that's the thing that I think you need in order to secure something like empirical confirmation. You need something more than just stuff distributed in a kind of Humean mosaic in a hyper-relational world. You need there to be some stability in the connections between things, because I think that's what a scientific theory tracks, is those kinds of stabilities.
Thanks.
Lucy? No, sorry, finger from Vera.
Yeah.
Okay, so Lucy.
Yeah, my question has mainly been covered, but I was going to just press you a bit more about whether you think time is a necessary feature of the conceptual framework that we use to navigate the world. Things like we all ate the hotel breakfast and arrived here on time. Is this something that we can reconstruct that fact without referring to time?
Yeah, so okay, here's I'll do it once and then I'll do it twice. So the first way to do it is let's replace all of that talk with causal talk. So there's a causal ordering. Your breakfast is causally prior to us having this conversation now.
Yes.
Right? And I think you can have a structure that's got causal ordering to it without that having to be.
Conversation without me having had the breakfast.
Sorry.
We could have had this conversation without the breakfast.
We could have had this conversation without the breakfast, but causally speaking, your breakfast occurs before the conversation.
Temporally speaking, not causally.
But that's what I'm saying. I'm saying get rid of the time talk. I'm saying you can because you asked me to reconstruct it, right?
Yeah.
So I'm reconstructing it using causal talk, right? So that's the first step. I'm going to reconstruct everything that you want to say about time using causal talk.
Breakfast caused the conversation?
No, the breakfast is if you've got a causal network of things and happenings, you can have an ordering over that network, and some things will be prior than other things in that ordering. But that doesn't mean that each thing is a cause of every other thing necessarily, although maybe you can add that in.
Maybe waking up is part of the cause of this conversation.
But I'm not saying that the things that happened prior in the causal ordering are the cause of what's happening now. I'm just saying that there's a causal structure and they occurred prior to the talk in that causal structure, right? So like maybe one way to think of it is you think of like the structures in sort of causal set theory, where you have this expanding, system of causal sets, and the thought is that maybe the world is like that, and you can reconstruct all of our time talk in terms of this other kind of causal ordering, which you don't have to think of as a temporal ordering, right? So that's the first step, and then I'm just going to say, well, look, causation is kind of weak, actually, and so you can even reconstruct it with something like counterfactual dependence between objects, and so that's where I'm going to sort of like push you back to causation and then push you away from causation even. And then you can keep talking about time if you want. I don't care. It's up to you. But, strictly speaking, I don't think that anything you're saying is true.
Okay.
If you were to start talking in causal terms or like in terms of the terms that I outlined here, then yeah, I'm happy to say that it's true. But I mean, this is all at the everyday level, right? And like I'm less concerned to recover everyday talk, I suppose. Except in these sorts of cases where you want to do it for scientific experiments.
Well, I'm happy with it becoming a kind of psychological question as to why time is somehow necessary for a conceptual schema that we use, but I don't think time can be eliminated from that.
From
sort of everyday experience.
I mean, like, there's
Interesting to speculate.
I mean, there's a question about whether you think, when you talk about eliminating from everyday experience, there's a question about whether you think you experience time. And like, I think you experience change, I think you experience causation. Is there something else that you experience over and above? Like, do you experience an A series, do you experience a B series? Maybe, like, people are going to disagree about that. I just don't think you do. And so I don't think there's anything in experience we need to recover. Our conceptual scheme is totally tied to time, I can see that, right? We think about time in we all have to get here on time when we think about that, right? And I'm not saying that that our conceptual scheme for the world you can take time out of that without cost in some sense, right? But what I'm saying is that you can still have a functioning science without it.
Yes, good. Thank you. Interesting stuff.
Thanks.
Okay, I want to ask a question.
Yeah.
So if we take the path where you say that the fundamental structure is not causal, right? So you want to have this kind of model structure or this structure, but you also want not to commit to the fact that it's causal. I just want to hear a bit more whether you think that we should be kind of primitivist about this kind of model structure, say something like, well, look, it's where we have to stop the explanation. Or think about, for instance, about Woodward's interventionism framework, right? So there are two options. Either you think that we stop at this level of description because it's how reality is, and there is no need to go further. And I think like it works like this because in the ontology we find causal relations described by, I don't know, any particular account. Or you might say just like it's an epistemic constraint, right? We don't know how it is if we go one step further, right? So are you more inclined towards this idea that the tracking is where we have to stop for epistemic reasons? Or do you prefer this idea that it's in this option maybe because there is one order where there is nothing more to say, like we just stop with those counterfactuals and we don't have to provide a kind of fine-grained story about why we have this counterfactual things.
Yeah, it's a good question. So if you look at, if you go back to Lewis on counterfactuals and he's plugging his Humeanism, part of the reason why he wants space-time in there is because he wants something across which to distribute the sort of Humean stuff, right? And then he wants to recover laws from the stuff that's distributed in that way, and then the counterfactuals get governed by the laws. So like which counterfactuals are true depends on what the laws are. So in that picture, the modal stuff is not really fundamental. It's kind of derivative on the laws, which are in turn sort of supervening on the Humean mosaic. So I think you could have a picture like that here. I think, so one thing I want is I do think that there is some like physical arena of reality. I don't know what that is, and I don't want to assume it's spatial, temporal, spatiotemporal. I want to leave it open what that is, and I want to some extent allow that a scientific theory could tell us that maybe it's not really spatial and temporal at all. But there's still some structure there, and I still want matter, right? So I still want to distribute matter over that. So then you can have a kind of Humeanism on that basis. in which case you like recover laws, stuff distributed across this structure, and then you can use those laws to account for counterfactual dependence in that kind of way. Or you could go the Armstrong route and say, well, look, there are governing laws. The laws, the world sort of unfurls according to the laws, and the counterfactuals come out of the laws, right? As long as, and this I think comes back to a later question, as long as you've got structure enough for rules, and those rules can support sort of modal claims, then that's what I want. And then I'm leaving it open as to how you want to deal with modality. But I don't see why you can't transfer a lot of those old debates about modality and laws into this context. It's just that we're not going to assume it's spatial and temporal. Does that help?
Yeah, very much. Chris?
Thanks. So initially, early on in the talk, you motivated the whole project with the difficulties one encounters when you try to understand how time or space-time emerges from a fundamentally non-temporal or non-spatial temporal structure, such as the explanatory gap that Baptiste has written about, or maybe the sort of the conceptual tools that we use were born and bred, I think, as you said, in a time-full universe, and therefore just don't help to do that. So if I understand, or maybe the conclusion for me then to draw is that it boils down then to balancing out the costs of trying to understand how time or space-time can emerge from something non-spatial temporal versus the cost of articulating a sort of a totally space-timeless, timeless theory, which would be empirically coherent and, moreover, I assume, empirically adequate. Mm-hmm. And so it's, as such, that's a fair balancing that one has to do. When I start to do that, though, I wonder what could possibly tip that balance in favor of the total timelessness. It seems that's a much bigger and harder project than trying to understand the emergence of space-time.
Yeah, what I'm trying to convince you is that maybe it's not, right? Because I think the ways in which it's hard have to do with empirical observation and confirmation. And as long as we can get that to work, I feel like it's not as hard as you might have thought, right? I agree that it's hard, and I agree with the picture, right? Yeah, you've got these two options: recover, don't recover, and then you've got to work out the costs in either direction. And all I want to do is try and like tip the scale, like tip it. Like I agree, it's like totally stacked against the timelessness type picture. I just want to like maybe move the scale up a little bit, right? And make a case that maybe the timelessness option is not quite as bad as we thought. And maybe from there we can even get them to parity where we can select an option. But yeah, I totally agree that it's probably easier to just come up with some new metaphysics of how emergence works. Like that's probably going to be easier. But like, let's try the hard thing.
All right. So let's have a last question from Al, and then let's take a break.
Okay.
No, very welcome.
Okay, thank you. So just, this is kind of related to what I asked at the very beginning. But, one is kind of, and related to what you said about the mathematical options.
Sure.
It seems like what you're doing with these counterfactual dependencies that are no longer seen as causal is to make them, in some sense, closer to the metaphysical or mathematical dependencies. So I'm wondering how we tell apart, like, the counterfactual dependencies, which kind of knit together the kind of structure of events from grounding or mathematical dependencies in this picture.
I don't think you have to.
Great.
If you don't want to, then don't. I mean, and if it turns out to be really hard to do that, then that's fine. Like, with a different hat on, I'm like a full-blown Pythagorean, right? I think that the world just is a mathematical object. So I think that all of these counterfactual relations just are counterfactual dependence relations between bits of mathematics. So I'm happy with that. But like, I'm not gonna.
I'm happy.
We can talk about that some other time.
Yeah, no, I'm happy with that too, but maybe the rest of us aren't.
Chris is not happy with that.
Alright, so let's then for now